This is Katie Kimberling with TutorPug, and I'm going to do a demonstration of how to use your calculator and the numerical method to estimate the value of a derivative at a particular number. We're given a problem that says the population of short-nosed gar in a lake is given by g of t equals 3t plus 26 times natural log t plus 9 fish t days after spawning begins. And what we want to do is use the numerical method to find g prime of 4. And then I also want to write a sentence of interpretation of our answer. So first of all, we're going to use the calculator and the numerical method to find g prime of 4, and then we're going to interpret our answer. So when we do this, there's lots of little details that you have to pay attention to. First of all, we'll have these tables. Usually these tables are given to you, but if not, you'll have to construct them. And I am going to, first of all, title my columns. So over here, what I'm doing when I use the calculator and the numerical method is I am going to find the slope of the secant line, and I'm going to use the limit of the slope of the secant line as that secant line gets closer and closer and closer to 4 from the left and from the right. So first of all, I have to say, okay, let's approach 4 from the left, and then let's approach 4 from the right. So some numbers that are really close to 4 on the left side of 4, 3.9, 3.99, 3.999. And I don't know how long I'm going to have to make this table. That will be told in the problem. And so let's say that this problem said that we wanted our answer to be accurate to the hundredths place. The problem will tell you the decimal accuracy that it wants, and that is a really important word because it tells us two things. First of all, it tells us when to stop running our calculations, and it tells us what to round to at the end. So I'm just going to put some skeleton values in here first, but I don't know exactly how long I'll need to go. I may need to add some more, or I may need to not go this far. Some values really close to 4 on the right side, 4.1, 4.01, 4.001, and again, I don't know how much I'll need, so I'll just stop right there for a second. Now I need to title the top right columns, and that is where I'm going to put the equation for the slope of the secant line. So in this example, I'm going to have the name of my function, g of t, minus g of 4 over t minus 4. And over here I'm going to put exactly the same thing, because that is the equation for slope. y2 minus y1 over x2 minus x1. And this just means, okay, we're going to constantly change the values of x, so it will constantly change the values of y. Now I'm ready for my calculator, and I have to do a little work here. The first thing I have to do is I'm going to go to y1, and I'm going to put my equation in there. So be careful of parentheses, they're very important. 3, and instead of t, I'm just going to use x, my variable key. So I'll do 3x plus 26, close paren, times the natural log of, oops, don't need that, x plus 6, 9, x plus 9. 3t plus 26 times natural log t plus 9, or x plus 9. Now, this is the really important part. We don't use y1 for our answer. In y2, we're going to put the equation for the slope of the secant line. So I'll show you two different ways. The first way is if your calculator has the ability to do the skeleton fraction where you hit alpha y equals and hit numerator denominator. If your calculator does that, then you are going to put y1 of x minus y1 of the number we're approaching, 4, over x minus 4. So if you have the fancy new operating system, that's what you want y2 to look like. If you do not have that, you're going to put the same equation, but it's going to look a little bit different because we can't make that numerator and denominator. So I have to use parentheses. This is very important. Open paren, y1 of x minus y1 of 4, close, divided by, open, x minus 4. So you need to make sure that that is what your y2 looks like. If you miss any of those parentheses, you will get an answer, but it will not be correct. Now we're going to go to our table, and I'm going to enter my values for x, but I'm going to read and record my answers from y2. Think of it this way. Why would you remember that horrible formula to put in here if you're not going to use it? So on the numerical method, you put the equation for the slope of the secant line into y2, and that's where you read your table values from. So I'm going to enter 3.9, 3.99, 3.999, and I'm going to go to y2, and I'm going to record all of the decimal accuracy. So for 3.9, I have 10.60605944498. And I'm getting that. If I highlight that value, it shows me all of the decimal accuracy at the bottom. And that's what I want. I want that for now. So my next value, if x is 3.99, the slope of the secant line is 10.61674122526. And if I go down to the third entry, 3.999, I have 10.617806651. So now we need to see, can we stop yet? Well, that's where this word comes into play. Whatever this word is, you are watching these values and you are waiting for every digit to be the same to one place to the right of this. This says hundredth, so I need the thousandths place or the third decimal place. I need everything to be the same up through the third decimal place. So here I have 10.606, 10.616, 10.617. Okay, well, the 1's the same, the 0's the same, the 6 is the same, the 1 is the same, but the hundredth says I've got to wait for this to repeat from one line to the next. So I need to run at least one more. 3.9999. Come back over here to x, 3.9999. And that gives me 10.617911317. So I have to have up through the third. Aha! Okay. They're all good. So this side is done. I want to go to the hundredth. I'm waiting for the thousandth to repeat. So I have to write a summary statement for this table. The limit as t approaches 4 from the left of the slope of the secant line is, and now I actually round to the hundredth, 10.62. So I'll run through this side very quickly. I'm going to come back over here and just overwrite 4.1, 4.01, 4.001, 4.0001. I want to read from Y2, 10.629728334, 10.619108166, 10.618043332, 1, 2, 3, 4, 5. Nope, not the same as that. Nope, not the same as that. So let's throw another one up here. And that gives me 10.6179367. 1, 2, 3, 4, not quite. So let's come down here, 4.00001, 10.6179263. Now we've repeated from one line to the next, so I stop. Summary statement here. It's going to look a lot like that one, but I'm approaching from the other side. Limit as t approaches 4 from the right. G of t minus g of 4 over t minus 4 is 10.62. So this statement summarizes that table. This statement summarizes that table. Now I have to do my final summary statement, which is what I was trying to find in the very beginning. So overall, G prime of 4 is 10.62. Now, the interpretation of that, I always start out and I have to say, what value am I approaching? What does this number mean in terms of the problem? Well, that's an input value, and my input value is days after spawning. So this should be 4 days after spawning begins. The output variable, the population of short-nosed gar. Now I either choose is increasing by or decreasing by. This is a positive number, so I say is increasing by, and that tense is very important. My calculated value, output units per input unit. Fish per day. That right there is an excellent example of a full summary of the value of a derivative at a particular input. Make sure you get this down. It's critically important.